Today, welcome to the Slumberger Academy. Last appointment through the break weekend. This is an anticipation of next course. Next course will come in 1 or 2 months, and we are talking about the well testing operation. Well testing operation is an essential phase of maintenance of all kind of wells. So is it from theory to best practice? We can go to analyze the drill steam test (DST) performing during drilling, temporary isolate and test formation, measure pressure and fluid response. Production test, measure flow rate, pressure, fluid type and composition, help estimate productivity, reservoir drive and depletion. Well is shut up in and after production period to monitor pressure build up. Method to use calculate permeability and skin factor reservoir boundaries. Also method to do injection and fracture using, for example, water fluid or CO2 injection or in disposal well. Measuring inactivity index and near wellbore condition. And multiple tests run as multiple flow rate test to underline the best capabilities of wells and best production. So it's clear that in next course we can analyze all these kind of aspects that is referred to maintenance and stimulate production. And also to recover abandoned old wells to regenerate production. Planning and objective, define clear test objective, for example, reservoir characterization, production, fluid and properties. Select appropriate test type, duration, well preparation, and also accurate measurements like use downward pressure gauge. Calibrate instruments before deployment, ensure boundary. Data quality and monitoring the flow rates in continuously. Recorded the PVT samples of fluid. Safety environment control. Perform acid sulfurous monitoring and control hazardous emission. Use well test separator and as the emergency shutdown system. So today we have just prepared a brief what we see a summary of simulation for gas well testing in sandstone reservoir. So we have gas test simulation for dual porosity and with multi-rate analysis. We have various parameters you can manipulate or change for this is a online app built up in Streamlight. For example, we have the initial pressure. So initial pressure is like this. We have initial pressure for reservoir. You can manipulate this or change. Plus, for example, enter. Gas viscosity, gas zeta factor, porosity, total compressibility, permeability, wellbore radius, skin factor, and also interporosity flow factor, wellbore storage constant that is expressed in second, and the total test time, that means for how many hours you make this test. In this case, we do for 24 hours, but we can build up also for 48 hours. There is 2 days. And data point. So with data point, we have this value, and you can build up this value. For example, estimate pressure drop. We have the first analysis is made for in around the gas flow rate. We have gas flow rate. We have width rate for the first 10 days. We have an increase in around the 10 days and after, and we have a constant value from 12 to 25, and we have also the flow rate well bore storage, the capability of other wells to storage gas. That is compatibility with the flow rate actually. The estimate pressure and gas pseudo pressure. It's important that underlined in that in gas well stimulation test, change, for example, the viscosity, that is essential parameters, and the viscosity change instead of the density of gas. So if you have much more, for example, propellers and not methane, we have a measured viscosity. We have, for example, also the porosity, that is a geological characteristics, and the total compressibility. The permeability is linked to clear to porosity, and well radius is a characteristics engineering characteristics of wells, and skin factors. We want to make up this kind of course because we want to link also geological to engineering aspect, because we need to speak around this kind to implement these tools for Stimulation. Thanks for attention, and what's we coming in next week.